long time. So now let's look at 5.1. Men and women often disagree on how they think about selecting a mate. Suppose that a pool of 1,000 individuals in their 20s gave the following responses to the question of whether it is more important for their future mate to be good looking or smart. So this is very similar to one example question from the PowerPoint slides. So this is what we call a 2x2 table. And the grand total is 1,000. It is given because a pool of 1,000 individuals in their 20s gave the following responses. So now we just need to complete this 2x2 table before we even look at the questions. Because for good looking, if we get rid of the gender, just look at among these 1,000 individuals, how many individuals think good looking is more important. Then we have 180 plus 120, that's 300. And then for smart, the same thing. The column total give us 700. So this 700 means 700 individuals think smart is more important. So that the total of these two numbers give us the grand total 1,000. And same thing for male and female. So among these 1,000 individuals, how many of the individuals are male? Then we look at 180 plus 420, so that's 600. And we have 400 female. So add up these two together, we got 1,000 as well. So again, 300, 700, 600, 400, we call those marginal total, and 1,000 is the grand total. And now let's suppose each individual in the pool has equal chance to be chosen. If an individual is selected at random, calculate the probability of the following events. So the first one, we have the selected individual is a woman. So we can say like A, because we all know we're going to use capital letter to represent an event. So let A be the event that the selected individual is female. And we can then write down the probability of the selected individual is a woman. Then we say probability of this event. So we define it using A. Then we can say probability of A equals. So F over N rule, we have the frequencies for female. Then the total is 400. The total count for female, 400, divided by the total, which is 1,000. So we have 0.4. 0.4. And now let's look at the second one. The selected individual thinks good looking is more important for a future mate. Good looking more important. Then we can define this using the letter B. Let B be the event that the selected individual thinks good looking is more important. Then for question 2, we have probability of B equals F over N. And then F is who thinks the count of the individuals, then good looking is more important. So good looking, we have 300 divided by 1000, which is the grand total. So that's 0.3. And then both event A and B occur, both A and B. So using the stat notation, we have probability of A and B. So then we look at the A event and B event. The individual should be female and also think good looking is more important. Then we have female good looking, which is 120. So still F over N, but that's going to be 120 divided by 1000. And then that's 0.12. And then either A or B occurs. That's the addition rule. So we just say probability of A or B equals probability of A plus probability of B minus probability of A and B. Then we can just plug in. So that is probability of A, 0.4, probability of B, 0.3, so 0.4 plus 0.3 minus 0.12, that's A and B. So that gives us 0.58. 0.58. Okay, so that's question number 4. And then question number 5. Neither A nor B occurs. So that's the one we're going to use complementation rule. Because we have either or already, then neither nor is the rest of it from the sample space. Then we say that's going to be the complementary event. So probability of A or B bar. We put a bar, it means complementary event. That equals 1 minus probability of A or B. So that's going to be 1 minus 0.58. That is 0.42. 0.42. That's for neither A nor B occurs. And now let's look at question number 6. Given that the selected individual thinks good looking is more important. So we know the stat notation for conditional probability. When you see this term given, you can write down this given notation. So it's just a line. Given the select individual think good looking is more important. Then good looking, we use event B represent that. So given B. And what is the probability of selected individual is a male. Then we have A represent female. The male is the complement of the female. So we say A bar. And then don't forget we're looking at that conditional probability. So that is the stat notation, probability of A bar given B. So that equals probability of A bar and B divided by probability of what is the given one. So if after this line we have the given event, then the denominator is going to be probability of B. Then for probability of A bar and B, so let's look at A bar. So we want to look at male who think good looking is more important. So I have male good looking. We have 180 of the count. So that's the F. And divided by total, the grand total, which is 1000. That's probability of A bar and B. And divided by probability of B, we have probability of B calculated, which is 0.3. So that's going to be 0.18 divided by 0.3. So that's going to be 0.6. 0.6. And we call this is the formula way to do it. So that's the first way we can solve this problem, the formula way. Or by the definition way. So the definition way going to be just look at the requirement. So given on B. So B is the selected individual thinks good looking is more important. So that's a condition. So when we have the given event as good looking is more important, that means we have a condition here that we only look at the good looking column. The rest of it, we don't look at those. Then when we say good looking is more important, we focus our eye on only this good looking column, and then we satisfy the condition. Then we can look at the probability. We want the probability of the selected individual is a male. So probability of the selected individual is male. Then we just want to look at probability of, again, write down. Male, we have the count of 180. So still this is an F over N rule, but with the pre-set condition there. So we say that's F star and N star. So male gonna be count of 180. And then N star means with that condition, what's the total? The total is 300 now. So we have 180 divided by 300, which is 0.6. So that's the second way. Just by the conditional probability definition, we know is 60%. And then the third way we can solve this problem is by looking at the independency. So we know A and B, two events are independent if they have no relationship. And then the probability of A and B equals probability of A and B equals probability of A times probability of B when A and B are independent. So let's verify this. So for this, let's put a star here. That means this method is only good for this question. For this question only, we happen to have, let's see, probability of A equals 0.4. So this is 0.4 times probability of B, which is 0.3. And probability of A and B is 0.12. So for this question, it happens to be like this. So we say they're independent. A and B are independent. If A and B are independent, then A bar and B independent as well. So A bar and B independent. Then we want to know probability of A bar given B. So A and B, they're independent. That means weather condition on B does not affect A because they have no relationship, independent. So that is the same as probability of A bar. So that's 1 minus probability of A using the complementation rule. And then that is 1 minus 0.4, which is 0.6. So again, using the third way, independently, we can still find out the question, but note that the third way is only good for the specific question, where you can find the relation that probability of A times probability of B equals probability of A and B. So most of the case, they're not equal, so you cannot use the independency for the other questions. And question number 7, given that the selected individual is a female, what is the probability of she thinks smart is more important? So for this one, we'll just use the first way, the formula way. So which is guaranteed that you can get a result if you can write down the stat notation. So probability of what is the probability of she thinks smart is more important. So we have letter B defined good looking, then smart gonna be the rest of it. So that's gonna be B complement. So B complement, B bar. So probability of B bar given what? Selected individual is a female. So that's A. So B bar given A. So we can write down that's probability of A and B bar by the formula divided by probability of A. So A and B bar. So A means female and B bar means smart is more important. So female who thinks smart is more important. We have 280 count. So the F is 280 divided by N, 1000. So we finish calculating probability of A and B bar. Don't forget, divided by probability of A, which is 0.4. So we got 0.7. 0.7. Or you just look at the condition, which is female. So condition, which is female, and then you have a total of 400, and then smart 280. So it equals 280 divided by 400. So same thing, you got 0.7. Or we know A and B bar are independent. So this is basically just looking at probability of B bar, and then probability of B equals 0.3, then probability of B bar, which is a complement, 1 minus 0.3. So you got 0.7. So that's the result. Okay, 5.2. A sample space consists of 5 simple events, namely E1, E2, E3, E4, E5, with the following probabilities. So probability of E1 equals probability of E2 equals 0.15, probability of E3 equals 0.4, and probability of E4 equals 2 times probability of E5. So we define event A as the set of E1, E2, E4, and then probability, and event B as the set of E2, E4, E5. Then we want to find the following probabilities. So probability of A. So probability of A equals what? So A consists of E1, E2, E4, and they're all simple events. Simple events means they cannot break down anymore. So E1, E2, E4, they're mutually exclusive. So then probability of A equals probability of E1, probability of E1 plus probability of E2 plus probability of E4. Just the sum of the probabilities of each simple event. Same for probability of B. So it's going to be probability of E2 plus probability of E4 plus probability of E5. So now let's see how to get those probabilities. And we know a sample space consists of these 5 simple events. So then we say sample space equals E1, E2, E3, E4, and E5. And probability of the sample space equals 1. Then we know probability of E1 plus probability of E2 plus probability of E3 plus probability of E4 plus probability of E5 equals 1. Then plug in the known information. Probability of E1, which is 0.15. Probability of E2, which is 0.15. Probability of E3, which is 0.4. And probability of E4 equals 2 probability of E5. So we replace all the known information. Then we can say 0.15 plus 0.15, that's 0.3, plus 0.4, that's 0.7. So 0.7 plus 2 probability of E5 plus 1 probability of E5, that's 3 probability of E5 equals 1. Then 3 probability of E5 equals 1 minus 0.7, which is 0.3. And probability of E5 equals 0.1. And probability of E4 equals 2 times probability of E5, then that's 0.2. Now we know all the simple events. Probability of E1, E2, 0.15, and probability of E3, which is 0.4. So we can write down the answer for probability of A and probability of B. So probability of A should be 0.15 plus 0.15 plus 0.2, which is 0.5. And probability of B equals 0.15 plus 0.2 plus 0.1. So that's going to be 0.45. And then probability of A or B, the addition rule. So probability of A plus probability of B minus probability of A and B. That's going to be probability of A. We have 0.5 plus probability of B is 0.45 and minus A and B. So how to get probability of A and B? Probability of A and B equals probability of so A consists of E1, E2, E4, B consists of E2, E4, E5. What is the overlap? That is A and B. So probability of E2 and probability of E4. So this is going to be probability of E2 plus probability of E4. That is probability of E2 we have 0.15. Probability of E4 we have 0.2, so that's 0.35. Don't forget to minus 0.35. And then we have the result as 0.6. A or B, 0.6. And then for A and B, we already defined it already. Then let's look at A given B. Just plug in the formula. So A and B divided by probability of the given one, which is probability of B. So A and B, which is 0.35, divided by probability of B, which is 0.45. So that's going to be 7/9. So we have this one, this one, this one, this one, and this one as the results. 5.3, two events EF are independent and probability of E equals 0.2, probability of F equals 0.6. Find the following. E and F. So by independency, probability of E and F equals probability of E times probability of F. So which is 0.2 times 0.6, that is 0.12. And probability of E given F. Because of independent, E and F, they don't have any relationship. So F cannot contribute on E. So probability of E given F equals probability of E. because whether put condition doesn't make any change. That's independency. Then probability of E equals 0.2. Then the result is 0.2. And E or of F. So that is probability of E plus probability of F minus probability of E and F. So that's going to be 0.2 plus 0.6 minus 0.12. So that's going to be 0.68. 5.4. How many ways you can select two letters from A, B, C, D, E? So that's going to be a combination problem. So we're going to choose two letters from this 5-letter pool. Then 5 choose 2. That's going to be n factorial n minus r factorial r factorial. This is n, this is r. So we have 5 factorial divided by 5 minus 2 factorial times 2 factorial. So that is 5 factorial divided by 3 factorial times 2 factorial. That's going to be 5 times 4 divided by 2. That is 10. So 10 ways. And 5 choose 3. 5 choose 3. That is the same as 5 choose 2, which is 10. So we have that formula. That is choose n from R equals choose n. Choose R from n equals choose n minus R from n. Okay, that's all for this worksheet 5. Thank you.